This video will cover steps to complete Excel Challenge Yourself Project 6.4. Before we get started, I do want to remind you that you do have access to the textbook if you are stuck on any of these formulas, functions. So to get to the textbook, when you're in SimNet, in the upper right hand corner, you have the option to click on Library. So once you click on the Library tab, you can see the different textbooks for this course. So this unit, we're working on Excel. You can click on the Excel book and choose a section. You want to click on Excel 2016, and we're on Chapter 6. So once you click on Chapter 6, now you can see the list of the different topics covered in this chapter. So for example, the very first step that we'll work on in this project covers the NPER formula, and you can click here and review that information if it's a topic that you're struggling with. So there's several other ones as we work through the project, and I'll try to mention them where they are in the textbook. So just wanted to remind you that you have this resource and you can go back. It'll take you through the steps just like it did in the training, so you can use it as a refresher or just a tool to help you get through these projects. So don't forget about that. So we'll go ahead and jump into the project. So let me pull up my start file, and so if you haven't already, go ahead and download the start file, and you may need to click Enable Editing. So now we'll go ahead and start on step 3. So this step says, on the loan terms worksheet, calculate how quickly you could pay off the loan if you increase the monthly payment. So there's a couple of sub-steps with this. So in cell D11, so I'll go ahead and click on cell D11 on my worksheet. It wants us to use NPER. So luckily it's telling us which formula it wants us to use. So I can go ahead and go to my Formulas tab, and the NPER is a financial formula, so I'll go ahead and click on my drop down, and I'll just scroll through these. They're in alphabetical order, and I'll click NPER. And now I have the function arguments dialog box open. So now as I read through these instructions, I kind of can work to figure out what value or what cell information I need to put in each of these items. So it says, remember to use a negative value for the payment argument. So I'm just going to go ahead and click in the payment argument and go ahead and put that negative value in there. Now I'm going to jump back up here, and it's going to tell me invalid. I just didn't want to forget to put that in there. Okay, so it also tells us we can omit the FV and the type arguments, so that's the last two. And notice here that rate, payment, and PV are bold. That means we have to have those values. FV and type are just regular font, so that tells us, that can help us easily identify that those values are not required. Okay, so what we want to do is in the rate box, we want to find our rate, which is interest rate in years. So because this is in years, that means when we select our interest rate, so we can type in cell B7 or we can click on cell B7, but that tells us that we have to divide it by 12 so that we get those years. And then it goes ahead and gives us the result of that formula there. Now I'm going to click back into my payment box, and my payment, I can actually find that we want to increase this monthly payment to $1,100. So that's what my payment will be. So I'm going to go ahead and click that cell. So now see, I have my negative D10 here. And then the last one, my PV, and that's the present value. And we can find that present value in cell B5, which is the amount of the loan. And remember, it told us to make sure that we didn't confuse the loan amount with the home price. So the home price is $230, the loan amount is $184. So make sure you click on cell B5, and then just go ahead and click OK. And that tells us that our loan will be paid off in 253.86 dot 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 months. So if we rounded that up, it would be 254 months. So our next formula wants us to figure out approximately how many years is 253 months. So for this one, we're going to use another formula, but this time we're going to go to the math and trig formulas. And we want to just round this number. So if we scroll down and find round, so the number we want to round is our months. And since this is in months, then we need to actually divide it by 12. And then the number of digits tells us how many decimal places. So we don't really want it to say, 10.2 months. We want to go ahead and round this. So we'll go ahead and put 0 digital decimal places, and then we can go ahead and click OK. So that's telling us that it's going to take us about 21 years to pay off this home loan here, this loan for $184,000. Okay, so our next step, step 4, it wants us to look up the equivalent fair market rents in the same area. So this data can be found on the final fiscal year 2017 Virginia FMR worksheet. So I'm going to go ahead and click on this tab. This is just kind of FYI information. The thing that the next step will reference is it's actually in Arlington County. So if you kind of scroll through here and you see Arlington County, and I don't see it right off. I thought it was in alphabetical order, but anyway, that's the information that our next step will actually refer back to. So in cell D16 on the loan terms sheet, so I'm going to jump back to the loan terms sheet. We want to enter a nested formula using match and index. So if you don't remember exactly how to do the nested formula, you can jump back to the textbook, and it's in chapter 6.8, talks about how to use a nested formula. So, alright, so we want to use the nested formula using match and index to find the fair market rent for a one-bedroom rental unit in the county listed in cell D15. So the county listed in cell D15 is Arlington County, and they tell us that they've already defined 2 named ranges for you to use. So when they have named ranges for us, we can come up here to define names, and if we look in this use in formula drop down box, we can see the defined ranges that they've already created for us. So there's 2 different ones, county and FMR 2017. So we'll actually use both of these in the next 2 steps. Okay, so to get started with our nested formula, the first thing we need to do is we want to start, the instruction tells us we want to start, I think it tells us we want to start with index. So if not, that is what we want to start with. So I am going to, index is in the lookup and reference, so I'm going to go ahead and click on index, and we get that select arguments dialog, and so we have the option to choose the first one or the second one, and I think the instructions tells us we want to choose the first one. So we want to use array, row, number, and column number. So you can go ahead and click OK. So for the array, this is where we actually want to put in our named range. So we can go up here to use in formulas, and we can click on that FMR 2017. So, and that tells us over here, it kind of gives us a hint that it has all the counties and that type of information that we want to compare in this nested formula. So the next thing we want to do is we're actually going to skip the row number and we're going to jump down here to the column number. And in the column number, the instruction tells us the one bedroom rent data is in column 4. So we can go ahead and type in column 4 here. Now we want to jump back up here to row number, and here's where we're going to put our nested formula in. So to do that, we want to come over to our toolbar all the way over to the left, and you should see index and the drop down option for more options. Notice our function library is grayed out. This is so to do our nested formula, we actually have to find it here to create that nest. And we want to use match. So go ahead and click match. And if you don't see it automatically, you can actually search for more functions. So I just happen to have used it recently, so it's in my list of frequently used. Okay, so lookup array or lookup value, it should be cell D15. So we can go ahead and click on cell D15, and this is our Arlington County. So we're comparing the rent price for Arlington County. That's the only thing we really care about on that the list from Virginia. And then our lookup array is counties. So again, the instruction tells us that they already created these defined ranges for us. So we can go to use in formula and we can choose counties. And then our match type, we want to type in, for this one we want to type in 0. And when you click on this match type, it kind of gives you a hint as to what you can choose. So match type is a number 1, 0, or -1, indicating which value to return. So now we can go ahead and click OK. And that tells us that rental options in Arlington County cost around $1,513. So if we want to check on a 2-bedroom rental, we pretty much want to do the same formula, except we want to check column 5 this time instead of column 4. So again, we are going to look up in reference in our function library. We want to do index again. So we want to choose this first option again. So our array will be the FMR 2017. This time our column will be number 5. And then we want to click in row number. And again, we want to go over here to this drop down list over here in the, to the left. And this time we want to find match. So again, what we want to match is cell D15, which is Arlington County. The array, again, we'll go to using formulas, is counties. And then our match type is, again, we want 0. So we can go ahead and click OK. And it's telling us a 2-bedroom rental in Arlington County will run us a couple hundred more dollars. So $1,746. Okay. So the next step, we'll move on to step 5. Now that we've calculated mortgage and rental options, so we've kind of went over how much it's going to cost for a house payment and how much it will cost to rent. Now we want to look at savings. So we can go ahead and click on our savings tab. And so step 1 says we want to save at least $10,000 for a down payment on a new car. So not only are we considering housing options, we are also considering vehicle options. So in cell B6, so I'm going to go ahead and click on cell B6. We want to enter a formula to calculate how much you will have saved by putting away $400 per month for 24 months at 1.75% annual interest rate. And we want to use the appropriate cell references. So remember to use a negative value for the PMT argument. So when we pull that up, I'll probably go ahead and put that negative in. And there is no money in the account yet, and payments are applied at the end of every month. So omit both the PV and type arguments. Hint, use the FV function. So it is giving us a hint on which function to use. So FV is a financial function. So if I can go up here to the function library into financial, scroll down until I see FV. Now I have that function arguments dialog box. And the first thing we're looking for is the rate. So we see the rate, the average annual return is 1.75%. So annual tells us automatically that we need to divide it by 12. So the NPER is the total number of payment periods in the investment. So we want to click on cell B5, and that tells us it's 24. And then on our payment, which remember we need to make that a negative, so I'm going to put my negative sign in there. Anything that's going out of our pocket, we have to put a negative in front of. And on this one, it will be B3, which is how much we're saving each month. So now we can go ahead and click OK. So if we're saving $400 a month, so we're taking money and putting it into savings, and the average annual return is 1.75%, it's going to take us 2 years essentially to save up close to enough to buy that car or have the down payment for the car. Okay, so now that we have the car part taken care of, now we also want to save for retirement. So I'm going to go ahead and click on cell B12. Now I'm going to enter a formula that tells us how much I will have saved by putting away the same amount, $400 per month, 25 years at 4%. So that will actually be kind of interesting to see. Okay, so again, we want to use the FV function. So again, we can go up here to financial, scroll down until we find that FV. Now we have our function arguments dialog box. So the first thing is we want to put in that rate again. So if it's 4% annual return, that means automatically we want to divide that by 12. The NPER is the total number of payments. So now this one's a little tricky, a little more tricky. When we did the car, it was already broken down into months for us. So that was 24 months. Well, this is 25 years. So that means we need to take that 25 years and multiply it by 12 to break it down into months. And you can see over here that tells us it's 300 months now. And then that payment is $400. So we're taking $400 a month and we're putting it into savings. And again, we need to make sure that we have that negative in front of the payment because that's money going out. Okay, so now we can go ahead and click OK. And this tells us that if we're saving $400 a month for 25 years at 4% interest, at the end of that period we'll have $205,000. That tells us that we will have saved $205,651.82, which is pretty good. Okay, so the next step, step C, so once we've saved 25 years, how much can we draw? So not only are we saving for a car payment and retirement, but after that time is over, we want to know how much money we'll actually be paying back to ourselves. So I'm going to put my insertion point in. I'm going to click on cell B14, and this time we want to use the PMT function to calculate the payments to ourselves. So the PMT calculates the payments for our loan based on constant payments and interest rate. So we're going to use it for, instead of a loan, we're going to use it to pay ourselves for retirement. So again, we can go to financial and scroll down until we see PMT. And so now we have this functions arguments dialog box. So again, so our amount is in, or our rate is this 4%, and we need to multiply it by 12. And so the input is the total number of payments for the loan. So this time we are paying it over 30 years. So we want to type in 30, and this time times 12. So we have that broke down into months. And then PV is the present value. So our present value is this $205,651.82. And it says enter a negative sign before the formula so the result appears as a positive number. So, and on this one we actually want to put a type in this time, and because this is, and there's a little note down here. Type is a logical value. Payment at the beginning of the period is 1. Payment at the end of the period is 0. So for this one, we're going to do a payment at the beginning of the period. So we want to put a 1 in there. And then I can just put my insertion point up here in my um, formula bar, and I can put my negative in up there. And that way, it'll make it appear in our result as a positive value. So go ahead and click OK. And so if I save $400 for 25 years, for the next 30 years I can pay myself $978.55 per month. So that's pretty cool there. Alright, so we've figured out our car payment, our retirement, and how much we'll earn from that retirement. So our last thing we want to do for this project is, I guess, annuities. So you have two options for additional guaranteed monthly payments in retirement annuities. So we want to go to the annuities worksheet. So the first annuity costs $20,000 and pays you $200 per month for 120 months, 10 years. So in cell B5, so go ahead and click in cell B5, we want to enter a formula to calculate the present value of this investment. Remember to express the payment argument as a negative number and set the type argument to 1 as the payment will be made at the beginning of each month. So, and it gives us a hint on this one. It wants us to use the PV function. So PV is the interest rate per period. So we can go up here to financial, scroll down to PV, and now we have that PV function argument dialog box. So here we want to click on cell B8 for our rate. So our interest rate is 1.5%, and of course we want to break that down into 12 months, so we want to divide it by 12. And our the total payment periods in an investment, so this one is broke down into monthly payments over 10 years. So we can just click on cell B6. It's already broke down into months. And then our payment, and remember to put your negative sign in there, will be B7. And so we want to click on cell B7. We're getting $200 per month. And then our instructions tells us to go ahead and the type to put in a 1 because these will be coming out at the beginning of the period. So go ahead and click OK, and this will be the $22,301.67 will be the value of annuity 1. Alright, so the second annuity costs $20,000, but it pays a variable annual payment. So in cell B13, we want to enter a formula to calculate the present value of this investment using the annual interest rate in cell B8 and the payment schedule in cells B14 to B13. So our instruction gives us a hint that on this one we want to use NPV. So again, we can go up here to Financial, scroll down and find NPV. So in the function arguments dialog box for this one, our rate would still be the same, B8. And again, for this one, because it's annual, we do not need to multiply it or divide it by 12. So our value would actually be this range B14 down to B23 because that's the values that were being paid each year. And so we can go ahead and click OK, and that tells us that over this 10-year period, the value will be $21,865.11. So that's it. You can go ahead and save this and submit it. If you have any additional questions, feel free to contact me. If you kind of are not clear on some of these formulas and functions and why we use them or how to use them, remember to refer back to your textbook or send me an email and I'll be happy to answer any questions you may have.